Hello, everybody. I'm going to switch over to my shared screen. Can everybody see the BOE ShieldBot cover slide all right? Okay, excellent. All right, well, welcome everyone to the BOE ShieldBot for Arduino PD. This is the two-wheeled or three-wheeled robot that you'll be building circuits on and programming over the next 3 workshop sessions. Those are going to be Monday, Wednesday, and Friday, March 6th, 8th, and 10th. For anybody who would like to follow along with the slideshow, I do recommend it because I put some links in here, and so you can have those links to follow at a later time. So here it is in the chat. First up, I would like to make sure that we've all got our screens set up just so, and we're running our Arduino software. And so for setting up your screen, first of all, what I'd like you to do is click View and select Exit Full Screen. Now, if you're on dual monitors, don't worry so much about it. Just set it up however is comfortable for you. But if you're on a single monitor, what we'll want to do is click View and select Exit Full Screen. And then you can put your, you can resize your Zoom window where you're seeing my presentation to one side of your screen so that you've got enough room on the other side of your screen to put your Arduino editor. And that might look like this, or this is the Arduino IDE that you may have downloaded and installed. And then this is the Arduino online editor. And either one of these are fine to use during the workshop. So just go ahead and set it up so that you've got your editor side by side with the window that has Zoom. And again, if you've got multiple monitors, just set it up so that you can at least see the the presentation on one monitor, and then you've got some room to work on the other monitor with your Arduino editor. A quick little bit about myself. I studied electronics engineering in college. Lately, I've been working on the Cyberbot robot. I've written a lot of educational textbooks for Parallax, and that's it about me. Another thing, we have some upcoming events. The Cyberbot robot workshop just closed. That one is full. We do have, though, coming up, if you follow the events link. So this is an example of one of the links that you can get to quickly and easily on the slideshow. You can see our workshop, and then the upcoming ones. And so coming up, we've got electronics with the microbit, a variation on the robot you'll be working with today. It's called the ActivityBot robot. It's got a multi-core parallax propeller processor on it. And then this is an in-person workshop coming up on June 4th in Seattle, Washington. So our online workshops, right now, there'll be more in-person workshops coming up posted for this summer. And then these ones up through May 5th are all online workshops like the one you're attending. A little bit about Parallax. The kits and hardware that we produce and distribute and manufacture are with an emphasis on either product design or inventing. They can be used basically for both, and we use them for both. So the things that Parallax make, you might find the onboard computer that we make, like the propeller microcontroller or the basic stamp or some of the others. You might find those kind of microcontrollers inside products. So for example, when you're using your microwave oven in the morning and you press a button on the front of it, it might beep at you and update its display. And the thing that was monitoring the button circuit was a microcontroller like the basic stamp or Arduino or propeller. Down along the bottom here, these are some inventions. All of these have basic stamps, actually. A little bit about Parallax. We are right in the middle of the state, just outside Sacramento on your way up to Lake Tahoe on Interstate 80 in Rocklin, California. We have 20 employees, have been in business since 1988, and we started designing and manufacturing educational things in 1997. This is Chip and Ken Gracie. Chip on the left is Parallax chief inventor, and Ken is Parallax CEO. And one of Chip's most widely used inventions was the basic stamp microcontroller. This came out in the mid-90s. And it really changed everything about both hobby and educational electronics, because this was the first device that did not require a high level of technical training in order to get started with putting something programmable and connecting circuits to it, and then writing a program to make the microcontroller monitor or control the circuits. Prior to this, it took, as I said, some significant technical training in order to be up to speed to program a microcontroller to interact with circuits. Now, since then, and incidentally, one of the first educational kits we designed was the Bobot robot with 2 wheels and a 2 drive wheels and a tail wheel, and a little area where you can build circuits. And the curriculum that went with it and the robot itself became very popular in schools. As other microcontroller manufacturers followed suit, when the Arduino came out, we adapted it to the BOE Shield bot. And then when we designed and started making the propeller microcontroller, we did a robot for that. And then most recently, the Cyberbot robot is got its own robot as well. So all 4 of these we still manufacture and distribute. And the main difference is if you have the original Bobot robot with the basic stamp, you'll be programming in a subset of BASIC called PBASIC. If you are using the Arduino Shield bot, you're using C++ in Arduino's programming language wrapper. If you're using the multi-core propeller, you might be doing it in Blockly or in standard C. And then with the Cyberbot robot, that is programmed in Python. I included links to some of the application examples that we'll be taking a look at, just to kind of give you a forward view. Oh boy, actually, I don't want to show you all these ads. Let's see here. I think I'll just go to learn.parallax.com and then go down to the Arduino Shield bot and then jump into the main tutorial. So this right here is the online version of the book that you've got. I'll go ahead and paste that link in. There we go. Okay, so just to try to resume on that set of application examples, here is the Whiskers robot.
One moment, Andy, did you intend to paste a link into the chat?
Oh, you know what? I think I pasted it by accident directly to somebody who chatted me. Okay, let's try again. There we go. Thank you, Stephanie.
Thank you.
Yeah. I don't know why. I guess I'll just suffer through the video or the advertising for a second. and show you because I can't seem to find it. There we go. So this is tactile navigation with little antennae that are built on the front of the robot. Oh, I see. We're using the ActivityBot 360 as the example. Basically, we do keep the examples consistent through all of our robots as much as possible. And so now that I know where to find those, I'll go back to learn.parallax.com and just quickly open the ActivityBot examples to show you. Let's see here. Okay, so here is, well, we saw navigation by touch. And so navigation by visible light is the next one. And as you can see, it's rolling along in kind of a uniform lighting situation. So it's more or less going straight forward. But then when a light gets shined on it, it starts following it. So that's an example of an application where you build and test a light sensing circuit, and then load another sketch that will allow the Arduino to monitor the light conditions and then turn the motors to follow the lights. And then here we have infrared detectors. And these, unlike the whiskers that stuck out in front of the robot and had to bump into something, the infrared detectors can actually see obstacles before it runs into it. And so those are the three major sensor systems that are that come with the stock robot. And then we have as later options infrared remote control. The gripper, which is pretty fun. And this is, here we go. And again, it's a slightly different robot, but you can put this on your Arduino ShieldBot as well. And we also have for your ShieldBot an ultrasound rotating turret with using a ping ultrasonic sensor, and hopefully you can see the little sensor going back and forth as it scans ahead of it to see obstacles. And it's on its way to the Maker Faire, which is, I don't know if they're having Maker Faires anymore. I really don't think they are. We also have color detection and a couple of others. I'll go ahead and skip those for now in the interest of time, but I have links to all of it here. Okay, so this week on Monday, we'll intro the Arduino, its programming language. We'll and then we'll connect everything up and adjust the servo motors. And after adjusting the servo motors to make sure they stay still when your sketch tells them to, we'll test it and make sure that the motors also turn, because we'll want the wheels to turn. And then between today and Wednesday, we'll have you go ahead and build that robot. Now on Wednesday, we'll build some of those circuit examples that we just looked at videos of. And between Wednesday and Friday, I might actually also have you, depends on how we do, have you try building and troubleshooting one of the sensor circuits on your own. That way we can have some demos on Friday, and we'll maybe work on one last circuit as well. Oh, we'll also talk about teacher resources on Friday. Okay, so here's here's today along with some resource links. Let's see if there's anything I should be pasting into you. I think I might come back to this to paste in some stuff later. And also I put a link to the robot kit in case you decide you need it to need to purchase some. Here is the link. And then there's also all things ShieldBot, which I'll also paste in that link. So that includes things that are added to that includes class packs, an enhanced 12 pack where in addition to 12 of the stock robots with the stock sensors, you get some other fun stuff like the rotating ultrasonic turret and the TV remote and a line follower module. And then there's also on this page things that can be individually added to your ShieldBot, as well as a ShieldBot without the Arduino, a ShieldBot with the Arduino, and other options and upgrade kits so that if you have, for example, a Bobot robot and you want to switch over to the Arduino, it's got all the parts for that. So I'll talk briefly about the homework that was done prior to this workshop. First up was making sure that you could load a sketch into your Arduino. And so hopefully everybody, can I get some thumbs up? Go ahead and use your reactions button and give me a thumbs up if you were able to get the light to blink on the Arduino. All right, looking good. Okay, good job, everyone. And then there was some homework and basically I just wanted you to try some of the essential basic programming tasks for the Arduino, and that includes storing and retrieving, basically remembering as in storing and retrieving a variable value, calculating, making decisions, repeating code, and that's mainly it. And so let's talk just a little bit more about that before going on to well, actually, let's see. Yeah, what I'd like to do is have you all get started with your either your Arduino IDE or your Arduino online editor. And we'll go ahead and instead of blinking a light, I'd like to try to make sure that everybody can also see messages that the Arduino can be programmed to send the computer. And so, I'll just start by pasting this sketch to you. And we'll have you open that sketch and try it out in your editor. And I'll try to do them in both. It's a little bit of a challenge because I'll be running back and forth between disconnecting one Arduino and connecting the other. So I'm not sure how well this is going to work. All right, so here it is in the Arduino IDE. And basically you'll need to make sure that you can see your a serial port here. And this might show, yes, so I have a question if you can use either one. I've only used the IDE in the past. Yes, you can either use the online editor or the one that you download, the Arduino IDE. The main thing about the online editor is that with a free account, it says that you get 25 compilations per day, which in the way I interpret that is after running after each time you load a sketch into an Arduino, that also includes a compilation. And so my understanding is that the limit is 25 sketch loads per day. I have not tested that. Might be worth trying out.
So just for clarification, you can use either one. Some of those who are attending have only used the IDE in the past, and someone has mentioned that they ran out of submits using the online editor.
Do you, for the gentleman who ran out of the submits, do you also have the Arduino IDE to use today? Excellent. Sigh of relief. Very good. Okay. So I take it then that 25 really is the ceiling. Okay, excellent. All right, so what we can do is once you've got your sketch entered into your editor, there's going to be an arrow pointing right somewhere. So in the online editor, it's right above the drop down for selecting your Arduino Uno. And it may, I'm running a Mac, you might actually see something like COM4 or COM and then some number for your serial port. You definitely want to see something next to Arduino Uno. Otherwise, you may need to go and start selecting your board and port. And your board is going to be Arduino Uno. And then it should show you a choice of one or more ports. And if you're ever in doubt, you can unplug the Arduino and then see which port disappears, plug it back in, and then choose that port. All right, so this is what it looks like here in the online editor. And then here in the Arduino IDE, it looks like this. And your right arrow is a little bit faint. So I'll zoom in on it. So this is what you would use to load the sketch into the Arduino with the Arduino IDE. And then this is going to print a message. And so another thing you'll want to be ready to use is the serial monitor. Now the serial monitor is in the upper right of the Arduino IDE, or if you have the Arduino editor, the serial monitor is right there. There are some small buttons along the left-hand margin of the web page, and the one with the magnifying glass will actually show you the serial monitor. So let's try this. Let's go ahead and upload the sketch to the Arduino. Hopefully you all have that connected to your USB port. Sorry, I didn't mention that earlier. And so it just told me that it was successful in loading. Now, since I'm in the online version, I need to use the serial monitor button. It's the little magnifying glass along the left. And it stuttered a little bit. It said H and then the whole hello. I'll close and reopen that. There's a nice hello. That's I've noticed that in most web editors, sometimes the communication messages received from the microcontroller get a little bit garbled until you close and reopen the serial monitor. So again, I see a hello right here. And I don't know if I can disconnect this. I just realized that I should have tested that. So I'll try loading it into, oh, did somebody say something?
We have a couple of questions. One is, what is the baud rate used for?
Okay.
And the second question is, mine has a little X next to the Arduino Uno. So
okay, the little X means that you're, I take it you're in the online editor?
Yes.
Okay, so the little X means that you need to run your Arduino create agent, and I'm looking for that. Let's see if I can. Are you on Windows? I guess one thing to do would be to click the drop down, and is there an X next to your port?
Yes, it's Windows.
Okay. And then if there's an X next to the port, for some reason it's not connected, and I see that they used the Arduino create agent, which was part of the homework, to basically add to install and test to make sure you could load a program before we got started today. So this is interesting. I don't know exactly why you would get an X. See, I've got the check mark. I take it that the X is appearing where that check mark is appearing on my screen. Okay, somebody posted an Arduino support link. Let's see. Oh, this is the Arduino create agent. Thank you for posting the link to it. And you can basically go to the page that was pasted in and hit the start button. Okay, let's see here. So Anne, does this mean that you got the that you installed the Arduino create agent? Is that right? Okay, yes. All right, so then in the Arduino editor, what you'll want to do is try, do you see the option for selecting an other board or port down here? Okay, so go ahead and click that, and you'll want to make sure to select Arduino Uno as your board. And then go to your ports and see if you have more than one port listed. And for some reason, mine just automatically, or you may need to click it to see the check mark, and you can probably click it again to disconnect it. So that's connected. That might be disconnected. Okay, let's see, anything more from Ann? We can also, okay. No port list. Generally, if you run the create agent, you may have downloaded it. Have you run it? And have you plugged in your Arduino to the serial cable? Make sure it's well plugged in. The USB cable is well plugged in at both ends. So on this end here, where the Arduino is, and then well plugged in your USB port on your computer as well. Interesting. So you do have the flashing light. Yeah, I don't know. We can try to help you a little bit during the break too. And I would say just tinker with this, see if you can, because yeah, the create agent needs to be running. If you have an X next to your Arduino, oh, I know, you may have another instance. Do you have another editor tab already open? Because that might be connected to your Arduino and preventing you from connecting via this. Or if you have an Arduino IDE installed and running, and that's connected, it's basically this serial port right here. So you can, for example, disconnect the serial port. And now hopefully, if I go up here and say tools, I just went over to the Arduino IDE. So tools, board, for me, Arduino AVR boards, Arduino Uno. So select that and then go back to tools, whoopsie, tools, port, and then see if you can find your the COM port for your Arduino and select it. And then hopefully you can use the arrow pointing to the right button to load your sketch in. And in this case with the Arduino IDE. Okay, good luck with that. And then we'll see if we can help you during the break. So what did you guys think of the homework? How many people, can I get thumbs up? How many people took a look, either took a quick look at it or tried it? It was all just the basics. Good, thumbs up, thank you. Okay, so yeah, it's just communicating, remembering. Okay, excellent. So with that said, I'll just, oh, Stephanie, go ahead.
You did, there was one question before that regarding communicating. What is the baud rate used
Oh, what is the baud rate? Thanks for reminding me. So the baud rate is basically the number of binary values per second that the Arduino sends to the computer. And the computer has to be ready to receive at the same baud rate as whatever is sending it data. Otherwise, it will not be able to make sense out of that data. And so by default, so the question is, can you switch to other baud rates? The answer is yes. If you have a baud rate, if you have a terminal that has a baud rate setting. So for example, I did just load it with the Arduino IDE. So I'll go ahead and open up the, hit the serial monitor button. And let's see, here it is. And so I'm going to try to open it again, see if we can clear that. Okay. So this is the baud rate selection on the terminal. And if you were to change the baud rate to say 115/200 here, you would also have to come over here and set this baud rate to 115/200. And then let's see if we can do that. Yeah, so there is also a baud rate on the serial monitor in the online editor. And so essentially, this is how to set the rate of bits per second, of binary values per second that you transmit and receive that the Arduino transmits and receives. And then this is where you can set that baud rate in the serial monitor, which is the software that's going to be communicating with the Arduino. Does that make sense? Are we okay with that? Okay, good. I'm getting some nods. Thank you. All right. The Arduino reference is going to be helpful if you end up starting with a sketch that has all kinds of great features that's using various things, some of which you may not recognize. I'm pasting this link into the chat. This is the place to go to look it up. So, for example, if I'm just going to add a delay of 2000 to this sketch. And let's say that the student had not yet seen delay. Well, one thing they can do is go and look up delay on this reference page. And here I see it down at the bottom. And we can open delay and take a look at the explanation, which is it's going to pause the program execution for a certain number of milliseconds, and that there are 1,000 milliseconds in a second. All right. And again, these were the basics that you already went through. So now let's go ahead and get started on connecting our, on setting up our board. So by the end of the day, this is what you'll have. Maybe minus the light emitting diode circuits on the breadboard here, because I want to focus on making sure that everybody gets their motors done, and then we'll come back and add those light emitting diodes if time permits. So the Arduino is underneath the Board of Education or BOE shield, and it's connected to batteries. And then we have 2 servo motors. These are the motors that make the robot roll, and we're going to plug those into the servo ports that are on the BOE shield. Let's do that step by step though. So the first thing I'd like you to do is grab these parts so that we can plug our Arduino into our BOE shield, and then so that we can also add, and then we'll make it into a little tabletop using these standoffs and these screws. And then there are some other screws you can use to, oh, I'm sorry, I apologize. These screws are going to be used or can be used to attach the Arduino to the BOE shield. Let me see here. Yeah, the 1-inch standoffs are going to be to make it a tabletop. I don't know why I only, oh, there are 4. I don't know why I just see 3 screws though. That's a little weird. So we want 3 longish screws, and then
I can explain there. You only need a short screw to hold the standoff to the underside of the board. Those long screws
oh, thank you, Stephanie.
were actually used to connect the Arduino to the underside of the board, going through these
nylon standoffs right here,
Yeah.
which we will be skipping. I just want to plug it into the shield, and don't worry about trying to use the long screws with the nylon standoffs. We're just going to get the 4 short screws here, and then the 4 long aluminum standoffs. Thank you, Stephanie.
Yeah, just basically adding table legs, and then the Arduino plugs in underneath.
Yep. And then when you're done, it's going to look like this. And I'll go ahead and do that with you. Is it safe to disconnect the unit from your computer? It should be. And that's true. We do want to unplug the Arduino from the computer before attaching it to the BOE shield. So you want to disconnect the Arduino from the USB cable for this. So there we go. The Board of Education shield looks like this. And by the way, well, I want to emphasize that these are all instructions that are coming out of the textbook that you also got with your kit. This guy right here. And I'm going to take just a moment. So it's, sorry, I didn't keep that. So this is the textbook that comes with the kit. And it also has an online version, but it's nice to have this printed version. And so for example, the picture that I showed you on the slide is also in both the online and the printed textbook.
Can I jump in with a question?
Yes, Stephanie.
A question I had once upon a time long ago: is it safe to just disconnect the unit from my computer? So can you just unplug it, Will, or do you have to disconnect it in the software in any way?
You know, that's a good question. Oh, hey, look, Anne, here's that X that you were seeing. So one thing I would suggest is to try, disconnecting and reconnecting your Arduino at both ends of the USB cable, because, now I have an X. So it knows that it saw an Arduino Uno and that right now it's disconnected. Let's see, Stephanie. Yeah, I do think that it is best to, for example, there was a disconnect button on the online editor. So right now I just plugged it back in. And so here we have my Arduino plugged back in. And if I run the sketch again, now I'll have 23 left. Oh, I forgot to put a semicolon after the delay 2000. Okay, when I go to the serial monitor, oh, that's right. I may have been on the other one. So I need to disconnect here. Ah, I think I saw it. Okay, so I want to disconnect here. And go over here and flash. Okay, so now let's see if I can open the monitor. All right, so the monitor is open. We see our hello, and there's a disconnect down at the bottom. And so I normally like to hit disconnect just in case the software does not handle the unexpected disconnection gracefully. So that would be disconnect here before disconnecting the USB port. And then if you have a serial monitor instead open on the Arduino IDE, it would be best to close that before disconnecting. And again, it usually doesn't matter, but just on the chance that that the software does not gracefully handle it, like I said, it's best to hit disconnect, and then just remember to hit connect, or in the case of the Arduino IDE, to reopen the serial monitor when you need it. Okay. Now, so again, the textbook has all the same pictures that I'm showing you on the slides, as does the online textbook in color, which is where these came from. And so what I want you to do is first of all, gather those parts, and those parts are listed on page 43 in your printed textbook. So you can use that as a guide if I switch away from a screen, and so you can still gather your parts. Now, once you've got your parts, the next pages are going to show you how to put the longer screws and the standoffs through the board, but we're going to skip that. Okay, all we're going to do is to get started is to plug the Arduino into the shield. And there's primarily one way that it should plug in, and you definitely want to have the gaps in the pins on the shield line up with the gaps in the headers on the Arduino. And then it should look like this. Make sure you've got it lined up first and that all the holes are started. And here's that gap that you'll be checking. And once you've got all the holes started, then you can press pretty firmly to get those pins to sink into the holes. And I'll show you that in real time. So there's a little plastic thing that you can just pull off the bottom of the Arduino. Careful though, don't set it down if you have a metal table. If you have a metal table, set it on the plastic thing. If you have a wood or plastic or anything like that table, then it's fine to set it down right on the table. And that shouldn't matter because we should have it disconnected from the USB port. And then here is the BOE shield. Go ahead and take it out of its plastic bag. There's going to be some foam on the underside protecting those long pins. Gently remove that foam. So those are the pins. And let's see here. So you can start like that, or I'm sorry. You can start by making sure that you can read the text on both the Arduino and the shield. And that'll mean that relative to the shield, the USB port and the battery power port are facing to the left. Then you can line up the sockets. Whoa. And again, don't press them in until you've got them nice and lined up. And that you can tell that you've got them started. I don't have mine started yet. There we go. I had to bend some of the pins in. So here it is on one side. Here it is on the other. We do have some empty sockets, but the main thing is you want that you want to make sure that I apologize, by the way, that the more recent Arduinos, what they have is instead of a space between headers, they actually have a spot where the pin cannot enter the header. Let's see if you can see that. Right there. And right there. So if you're able to get the pins started, it means that you've got everything lined up just right to begin with. Okay, so it looks like I've got them started on this side. Started on this side. So now we can squeeze it very firmly together. And you'll feel it stop after it sinks about 1/4 to 3/8 of an inch. And there'll still be some pin visible coming out of underneath the shield. Okay, how are we doing? Thumbs up? Oh, good job, everyone. Okay, give me a shout out if you need me to stop or slow down for anything. So then the other thing we want to do is find those. Now the little screws to make it a tabletop are going to be in this clear plastic bag. And so what you want to do is pull out 4 of the short screws and then 4 of the long metal tubular standoffs. Okay, so I'll throw this back in the box for now. And see if I can use my hands to open this bag. Yes. And then one of the homework items was to have to go and find a bowl or tray or something like that and some batteries. Now we'll want to keep the batteries separate from the metal parts, but what you can do is you can empty out your mechanical parts into your bowl or tray. And then do keep the batteries somewhere off to the side. Then we'll go ahead and grab 4 of the longer standoffs and 4 of the shortest metal screws. So those are the standoffs. And I'm off screen grabbing the short Phillips pan head screws out of the box. And there we go. And then all you have to do is put the screw in the top corner, put one screw in each top corner. Well, do it one at a time. So once you've got the screw in the top corner, you can just screw the standoff onto it until it's cinched to the board like that. And again, these are instructions from the book, but it goes faster when we do it live with the video. And there we go. Okay. Give me thumbs down if you need more time, or thumbs up if you're caught up with me. Thumbs up, thank you. 1, 2, 3, 4. Oh, lots of thumbs up. Okay, good. All right. Next, we'll go ahead and reconnect the USB cable. Now, when you disconnect and reconnect it, since I didn't add the screws and nylon standoffs that are used to really keep the Arduino attached, I usually kind of try to hold on to the Arduino a little bit as I remove the USB cable and plug it back in. Okay, next up. So just a few excerpts from the book that we might be able to loop around back to, depending on how our time goes. One is that the breadboard that you see, which is this area with a whole bunch of sockets, is organized so that we have sockets that are labeled for certain voltage levels, sockets that are connected to certain Arduino I/O pins. Ground is a 0-volt level, and then there are some analog input sockets and an analog reference, which is not really within the scope of our class. So if you want to connect 2 or more wires together or part leads, just pick a row of 5 sockets and then plug 2 or more parts into the same row of 5, and they will be electrically connected. So just as an idea, if you pick a row of 5, these are examples of blue and yellow wires that are connected. So here's a row of 5. Here's a row of 5. It didn't matter that there was a space between these. It's just the row of 5. As long as you're in that same row of 5, you'll electrically connect 2 wires. And you can even jump a wire between 2 rows of 5 so that you can have 8 remaining sockets to connect wires together as well. Examples of not connected that you can quiz your students on would be these 2, since they're in separate rows of 5, and these 2, since they're on the same row, but it's not the same row of 5, it's the 5 on the other side of the well that's between the two terminal strips.
We have a question about whether the breadboard on this are the same as any other standalone breadboard. And I would say yes, in the way that these groups of 5 are connected underneath with a central well in between that separates them. But you might want to explain where the power and ground rails come in.
Yeah, so the breadboard itself, the white piece of plastic, is just a plain old breadboard. It's small compared to, you know, you can get, it's probably one of the smaller size breadboards that you use for electronics and electrical prototyping. They can be much larger and more involved. The difference is the fact that this breadboard is set inside these sockets that provide electrical connections for you. And these electrical connections are pretty standard if you look at our robots, but they do vary a little bit from one robot to the next. And it's not something that you would necessarily see on some other shield or other breadboard system. So these you will find make it fairly convenient to connect to all the things you need, the power with our voltage levels here and ground down here, and then the Arduino sockets along the left. So that is something that's not standard, but it's also not really the white breadboard either. It's some sockets that are next to the breadboard itself. In the book, we go over, in addition to how to connect a pair of wires, we go over resistor values and their color codes. Again, if time permits, I'll swing back around to this. We talk about a light emitting diode and how if you apply voltage to it using a battery, that electrons will flow through the circuit and cause the LED to emit light. And we talk about how a light emitting diode or LED has pins that indicate how it relates to its schematic symbol. We introduced the schematic symbol for the LED and for the resistor. And then we have the students build some circuits and try a program to make the lights blink. We explain how that works inside the Arduino. And so after they've run the sketch and tested it out and gotten their light to blink, we explain, hey, when digital write 12, high gets executed, the Arduino delivers 5 volts to the socket labeled 12. And digital write 12, low, internally the Arduino connects ground to that 12 socket. That's and that would be, in this example, digital 12, which is right near the top along the left of the breadboard. We also introduce timing diagrams. That's since they can see how long the light stays on and off. And we do some additional activities to cause the light to be on and off for different amounts of time during its full on-off cycle to just basically introduce or work towards the kind of signals that the Arduino sends to the servo motors. And what we'll do is we'll get started connecting the servo motors and batteries to the Arduino after the break. It's 2 minutes past the hour right now. I'd like to reconvene at 10 past the hour. And also, Anne, if you still need some help, we can pause the recording and then help you out with your connection. Oh, Anne had to reinstall the agent again. Well, I'm glad you got it working. You didn't miss much. Okay, well, good.
I'm going to pause the recording.
Okay. Thank you. All right, welcome back from the break, everyone. So as promised, we're going to get started on the servos next. We do have one question about the nylon spacers. So let's see, I want to make sure I get back to the right slide. I am currently on 37, and we're going to go back to the parts. So these nylon spacers and these slightly longer screws are used to attach the Arduino to the shield. And I think actually only two of the Arduino design has changed enough that now only two of the three attachment points work, but it is one way to cinch your Arduino down to the shield that it's plugged into. And so if you want, while you're putting a robot together between this and the Wednesday session, you can use the screws and the nylon standoffs to better attach the Arduino, or to fix the Arduino to the board. So we're using, basically it'll go into, so here's one of the holes, and then here's two more. And basically the spacer will go in between the shield and the Arduino. Then there'll be a screw going through each of these holes. And then underneath these holes, you'll use the nylon nut to tighten it down. And so that's, again, something that you can do. Was that visible, or did I have the Arduino hidden by the editor? Could everybody see what I was talking about? Okay, I got some nods. Thank you. Give me a shout out if there's still some confusion. Anyway, that's something you can do between this session and the Friday session. So here are the servo motors, and what we're going to do is make sure that the power is off. So find the little 3-position switch, and even though you're connected, make sure that 3-position switch is all the way to the left to 0. So this is the 3-position switch, and you want to make sure that instead of being on, you don't want to see these little power lights. You want it all the way to the left over position 0. Next up, and this is something that you won't need to take any action on. It's basically there just in case you're using rechargeable batteries, or we're using alkaline batteries for this. And so you should have 5 new alkaline batteries. And the voltage that alkaline batteries would give the servo motors is slightly outside of their spec range. And so what we do is we set the power that the servo port delivers. V in would be direct battery power, and 5V is regulated 5 volts. And there's 3 pins here, and there's a little sleeve between the 2 servo ports, and that sleeve is over the upper and middle pins. And what that does is it sets the voltage delivered to the servos to 5 volts. So don't change this, just leave it as it is. And it might be visible to you. Here is the little sleeve, and it's over the upper 2 pins, which is as it should be. 5 volts to the servos. And then what we're going to do is we're going to get the servos out of our box and plug them into the pin 13 and pin 12 ports. Those are the ports to the left of, those are the two servo ports on the left side, and then we'll leave 10 and 11 empty. The servos are in with the metal chassis. And while you're in with the metal chassis, grab the battery pack too. So you'll need the two servos. And the battery pack. And then we can set the chassis back in the box. All right, so then the next step, and I'm going to give you a page number here so that you can use it as a reference. The servo connections are on page 62 of the printed text. So if you need to look at that, here it is on page 62. And so on page 62, it explains to see our battery pack might already be connected. I think that was an earlier step that I may have skipped. So, but first we'll go ahead and connect the servos, and be careful to make sure that the white wire of the servo port or of the servo cable is on the highest pin closest to the number 13. And same with the servo connected to port 12. We want the white wire closest to the number 12. So I'll go ahead and line up my white wire with the number 12. And then plug it in. And then make sure the white wire is by the socket aligning with the pin closest to the number 13. And then plug that in. And then last but not least, I'm not sure where it was in the book, but we'll go ahead and take the battery pack and connect it right here to the Arduino's barrel jack. That's the barrel plug of the battery pack. This to the barrel jack in the Arduino. And then finally, put your alkaline batteries into the battery pack. Like so. All right, how are we doing, everyone? Thumbs up? Lots of thumbs up. Good. Thank you, Marcel, and everyone else. Okay, so now I'll go ahead and have you load a sketch. Let me make sure this works first. Compiling, compiling, compiling. Okay, good. So it looks like this is going to work. All right, so this sketch is similar to one that you will find on page 65.
Did you see the question, can you please explain the switch next to the 12 where you put the white wire?
Can I please explain the switch next to the 12 where I put the white wire? Let's see here. Are you talking about this little jumper right here? Yeah, so the jumper is set to 5 volts, and what that does, there's two different options. There's V in and 5V. See if I can get a close up of that. Sorry if anybody's getting seasick. All right. So this jumper switch right here is currently a sleeve that's connecting the upper two of these 3 pins between the servo ports together. And what that does is the upper pin is 5 volts. The lower pin is unregulated voltage, as in the battery pack voltage. And so since this sleeve is covering the upper, it's covering the upper two, which is 5 volts, and then the center, which is the power that goes to the servos, that sets it to deliver 5 volts to the servos, as opposed to the battery voltage, which is just a tad too high for the specification of the servos. Okay, did that explanation make sense?
Yes.
Okay, thank you. All right, so centering the servos, what you'll need to do is you'll need to run that sketch. And when you turn the power on, what's going to happen is that the servo connected to P12 is going to rotate slowly. And what we want it to do is be stopped when we're sending that stay still signal. So to do that, what you want to do is go into your robot parts box and find the Phillips screwdriver. And you'll use the Phillips screwdriver. There's a little hole right here, just above the cable that comes out of the servo. And you'll use the Phillips screwdriver, and you want to be very gentle. Imagine you're a surgeon when you're doing this. You want to use a very light touch. And that little yellow circle in there is actually a Phillips drive. And so you'll use the Phillips screwdriver. And when you go in, you might turn it one way and it starts turning faster. And then if you turn it the other way, it'll turn slower, and it might actually reverse directions and then start turning faster in the other direction. And what you want to do is search for the setting, search for the position of the screwdriver that makes the servo horn stay still. So now it's not turning anymore. So again, if I adjust it a little bit, it might turn one way. If I adjust it a little bit, it might turn the other way. And what we're doing is we're searching back and forth until it stops moving. And you also don't want to feel any buzzing inside the servo case as you're holding it. So right now, this servo is officially centered. It's receiving the stay still signal, and it's staying still.
We have a couple of people reporting that theirs is not moving at all.
Okay,
So-
that might have been because I forgot to tell everybody to set this 3-position switch to position 2.
Yeah.
Sorry, everyone. So right here, this 3-position switch needs to go to position 2, and then you'll see one of the servos, the one connected to port 12, start to move.
Now, if it's not moving at all, but the power switch is on, could that be that the servo is maybe plugged in backwards?
You know, that's a possibility. I mean, I suppose it's not impossible for a servo to be a little to be properly centered straight out of the box, but very rare. So yeah, check. Do you have a green light next to your breadboard and another green light next to the servo ports?
We have a couple of people reporting the situation, so.
Okay. Did you load the sketch?
So we have an only one light from Marcel.
Okay, so Marcel, make sure that your batteries are all the way in. And make sure that their polarity is correct. You always want to have the flat end of the battery near the up against the spring. Then make sure that.
I think the fact is a lot of people are asking for the sketch.
Okay, so did I forget to put the sketch into the, oh man, I'm sorry about this, everybody. Let me put that sketch in there. Okay, so there's the sketch. It's similar to the one on page 65. I just pasted it into the chat. And so what you can do is paste it into your Arduino IDE or your Arduino editor, and then hit the right arrow upload button. And it'll compile and load the sketch. And then when you have the board on with the power set to 2, after the sketch loads, here I'll uncenter this P12 servo. The servos should start turning.
Andy,
And
I
you
think in
can't
the
see
copy and
that.
paste, you miss the last curly brace.
Sorry, what was that,
Oh.
Ari?
I think you have a missing, the last curly brace is missing on the copy and paste.
Uh-oh.
Oh,
That's probably what it is. Okay.
so those of you who it's taking a long time to upload, it might be not compiling.
Yes. Oh boy, I apologize for that. My camera, I have a camera right in the center of the screen, and it covers some detail. So I'm sorry I missed that. I just pasted in the corrected sketch with both curly braces so that you shouldn't get a compiler error now. And then once it starts turning, use the Phillips screwdriver to gently search for and find that position for the set screw to make it stay still. Hey, motion detected. Thanks for the update, Ann. All right, so how's everybody doing? Can I get some thumbs on 1, 2, 3? Got 3 thumbs up, 4, 5, 6, 7. Oh, great. Everybody's doing really good. I got 1 thumbs down, so we're gonna wait, and do feel free to either chat or unmute yourself if you need some help.
Hey, Andy, I still have no movement.
Oh, so I see that 1 servo is not responding, and still no motion using new batteries from Nilu. Okay, are you, I guess the next questions would be, so there should only be 1 servo moving. We focused on the P12 servo, so we're leaving the P13 servo for in just a little bit. So, so your checklist should be, first of all, did you run the second script that I pasted in? Not the first one. Did the Arduino editor report that it successfully uploaded the sketch? That's one. Then looking here, you want to have both green lights on because you have the switch set to 2. And then you want to have your alkaline batteries in the battery pack, making sure that the flat ends of the alkaline batteries, each one is up against a spring. And then make sure you're well plugged in here. And then last but not least, the Arduino needs to be well connected. It needs to be pushed all the way down onto those pins. And so hopefully in my screen, you can see the relative distance that it's pushed in. There's only maybe 1/8 of an inch left of the pins, and then the rest have sunk into the socket.
Also make sure that the servo is plugged into P12 and it's not header up there and it's not plugged in backwards.
Thank you, Stephanie. Yeah, so as she said, make sure that the servo plug is properly plugged onto those servo pins, and that should also sync 1/4 to 3/8 of an inch when you plug it in. So if I plug this in, I'll unplug both.
Maybe you could show a close-up. All checks. I can turn the motor with hand. Maybe batteries are the issue.
Possibly. So on the close-up, we get the plug started on the pins. Make sure they're going into the holes and that it's not next to it, and then push it down by about 1/4 of an inch.
Yeah, observation from Brian, if it turns easily by hand, there's no power making it to the motor likely.
Yeah, Brian is correct. But you say that this light is on right here?
Both lights are on for you? Yes? Both.
Okay.
So then it could be that no command is making it to the IO pin.
Yeah, that is a possibility. So let's repaste in that sketch. Make sure that this successfully loads into the Arduino.
Okay, I just saw you shade. What you're shading did not include the last 2 curly braces.
Oh, thank you. There they are.
No, okay.
Everyone
And
paste.
make sure that include servo.h is at the top.
Yeah, so you want to shade this, the entire sketch that I pasted into the chat.
And the jumper in between those servo ports needs to be connecting to 5-volt pin and the center pin.
Which is the way it should have come out of the box.
Yes. Motion, yay.
Oh, good.
So it
So
might have
now
been in
go
the
ahead
code.
and use the Phillips screwdriver to. By the way, Nilu, what was was it when you loaded the script in? Okay. I think we're ready to move on to the next servo. Good job, everyone. So for the next servo, the sketch is on page 66. But what I'll do is I'll just show you how to modify this to run it, and then I'll paste it in. So we're going to change servo right to servo first. Actually, in fact, for the sake of time, I'm going to control both servos at once. Okay, so I'm adding a servo left. And then we'll attach the servo left to pin 13, pardon me. And then we'll also send that 1500 stay still signal to servo left. All right, and I'm gonna first paste this and hope that maybe the oh. See if the online editor is any faster on the test. Try flashing it here. Connect. Oops. Okay, so I was just able to verify that that the P13 servo is now turning and ready to be centered. So I'll go ahead and paste this sketch in. Okay, so there's the modified sketch. It controls both the left and right servos. The right servo is already centered, and so it's staying still now. And now the left servo needs to be adjusted. Okay. So now both of my servos are staying still, but that's not as important as your servos staying still. So go ahead and give me a thumbs up when you've got the sketch loaded. And then, okay, wow, Marcel, that was fast. So everybody's got their servo centered? Good job. Do send me a thumbs down if you need some more time. Or give me a shout or send a text. Otherwise, let's, okay, so a question from Anne, should they stay still from now on, or do you need to adjust them regularly? Okay, that's a good question. Occasionally they need to be adjusted a little bit after a certain amount of vibration. But in general, they're pretty good about staying still. And I'll talk about how to recenter them when they're in the robot. I think on Wednesday, I'll want to talk about that. I'll just do a quick demo of how to recenter them if they fall out of center when they're in your robot. And so these two slides talk about how to do that. And then here is a test sketch that we'll want to try out. And what the sketch does is it makes the servo turn, see here. So this sketch is from page 70, and it makes the servo turn, that both servos turn full speed clockwise, then counterclockwise, then stay still. And so they turn clockwise for 3 seconds, counterclockwise for another 3 seconds, and then stay still indefinitely. And I'll just modify this so that it's ready for you to go. And my keyboard stopped working. Or let's try it here. Okay. The reason I'm uploading a second time rather than pasting it into, here we go. Okay. Now it should make my servo motors turn rapidly in one direction, then rapidly in the other, and then stop. So I'm going to paste this in. And looks like I got all of the sketch this time. Okay, so there's the modified sketch. And sorry about the indentation problem. Huh. Now, if you want to restart the, so make sure to load that sketch into the Arduino. And then after you do, they'll rapidly turn one direction and then another and then stop. And if you want to restart the sketch, you can press and release the reset button right here on the board. And so we want to see them turn rapidly counterclockwise, rapidly clockwise, and then stop. And while they're stopped, if one of them is turning ever so slightly or making a buzzing noise, you might want to just kind of finish off the centering on that particular servo. Okay, I have one not working report. Did you get any messages other than the done uploading on your Arduino editor?
Yes, it said that missing FQB in fully qualified board name.
That almost sounds like, are you using the IDE or the editor?
IDE.
Okay. And
Oh, hold on, my board's not selected for whatever reason. Maybe that won't work.
what did you find, Marcel?
The board wasn't connected,
Okay.
but I just used it. But okay.
Okay, now when you
will-
reconnect the board and you try the upload right arrow button, is it uploading?
Yeah, it worked now.
Okay, good. And then do you get the whole turning rapidly?
Yes.
Okay. So notice that when it turned counterclockwise, we had a value that was larger than 1500. And when it turned clockwise, it was in response to a value that was smaller than 1500. Now, these values of 1300 and 1700 are what you could call overdrive. They're actually asking for more speed from the servo that it can actually give you. So 1300 above 1500, so that would be 1430, is roughly top speed. And so if we want to go half speed, it should stay still at till like 1506. So let's see here. So roughly, and I'm very approximate here, roughly half speed would be, let's see, 130 over 2, that would be 65. Let's say 70. So 1570. If we were to try, and I'll have you guys try this on your own, change the 1700s to 1570s. And then change the 1300s to 1430s. And try that. Try your modified sketch with 1570 and 1430. So do it for both servos. We'll have them turn the same speed. And after my sketch loads, they should be turning visibly in both directions. And I'm going to go ahead and bring it down to maybe a quarter speed. So that would be 1535 and 1465. And they should, on the screen, turn visibly slower. I'll replay that by pressing and releasing reset on the board. So how are we doing? Have we proven speed and direction control? All right, good job. Did everybody get to try both the 60, the 70 and the 35? Okay, and keep in mind that's 1500 plus or minus your speed. And there is actually an activity that the students do on page 69 where they fill in some of those speeds to get used to the speed and direction control. So there is an excerpt from page 69 where they are controlling the speed and direction of the servos. And there's also an activity starting on page 93 where you're running a sketch where you actually count how fast the wheel is spinning, and then plot it. And this is roughly what the control, we call it a transfer function. And basically notice that up around 130, so 1500 plus 130 would be right about there. And we're definitely at top speed, and then it gets slower and slower and slower, stops at 0 RPM. So this is up at around 50 RPM. And so like 1550 will give you slower, 1525 even slower. Then it stays still down in the 1500. And then as you go lower, then it starts turning faster and faster in the clockwise direction. And with that, your homework is going to be these pages, 77 through 85 and 90 through 92. So 77 through 85 is putting together your robot. And so this is an example of what you're going to see in the book on page 77, where it's going to show that you grab, you'll actually need to unscrew the standoffs that you had on your BOE shield. You'll need to unscrew these front standoffs right here, the ones under the breadboard. And you'll be attaching those to the front of the robot chassis. And aside from that, you'll just be going step by step through and saying, okay, here's the before, here's the after, and here are the checklist instructions that you'll be following along with. And I need to look up 90 through 92. I suspect that's going to be a piezo speaker.
Oh, we have a couple of other things to note.
Okay, Stephanie, go ahead, please.
The one of concern is I unplugged the battery pack and the motors are still running. Would that board be connected to the computer still?
Yeah, so it's drawing power from the USB port, and we don't want to do that, especially if your servos are turning slowly. It can still work, but if your servos are turning at full speed, and especially if they run into like some resistance against their turning, it could draw more current than the USB port can provide, because the USB port also provides power. It provides 5-volt power, but that's primarily for the Arduino. So what we want to do is when we, oh wait, I'm sorry, you said when you unplugged the did you unplug the battery or the USB port? Sorry about that.
Turned the switch off and they stopped, but initially it was, I unplugged the battery pack and motors are still running.
Yes, okay. So yeah, that can happen. And the best thing to do, as you mentioned, it does get power. It can get power from the USB, but it's not recommended. We want to supply the power from the batteries. It varies from one computer to the next, how much power it can supply through the USB. And so we generally keep the battery connected, especially when we're doing anything with servo motors and position 2. If you're in position 1, when you're in position 1, the light will be off, and or rather the light next to the servos will be off, but the light next to the breadboard will still be on, meaning that any circuits you have on here are still receiving power, and those are typically okay to run straight off of the USB power.
Andy, quick question.
Yes.
I went ahead and I added the nylon spacers,
Uh-huh.
and the two next to the breadboard are the only ones that fit. You were mentioning something about not being able to use 3, right? We won't.
That's
be able to use
correct.
that one
And
in the
so
front.
that
This
third
doesn't fit.
one next to the in the upper left corner
Okay.
is the one that no longer works with the updated Arduino design.
Okay, just making sure.
Yeah, I think you're in really good shape there. Okay, and do we have any other questions? So this is the main thing that that I wanted you to try, and now 90 to 92. Let me see if I can find that, because what we're having you do again is put together the robot, and that's 77 through 85. And then 90 to 92 is going to be plugging a piezo speaker in. And so what you'll be doing is you're going to want to make a note of which rows those pins went in, and they have to go across the little valley. And then it'll give you a sketch to try out. And well, first of all, though, we have to finish the circuit. Sorry about that. So you'll start by finding the piezo speaker. It's going to be in an electrical parts bag, which looks like this. You'll see a bunch of wires and other stuff, and there's going to be a piezo speaker, a little round, solid plastic thing. Let me see if I can find it. Okay, it's going to be in the bag with the LED lights. It's this little guy right here. So that's the piezo speaker. And be careful, as I mentioned, when you're putting it into the breadboard, because it's really easy to put the pins into a pair of, when you plug in the piezo speaker, you'll push it all the way in, but then it's hard to see where those pins are actually going. So make a note of which rows the pins went into, and then you'll use a jumper wire to connect to P4. And there is no green jumper wire in your kit. Use yellow or blue, although you can use any color, but yellow or blue would be more common. And then run a black wire from this row to ground. And then this sketch should allow you to make the piezo speaker make a beeping sound. And that is, again, pages 90 to 92, and then 77 to 85 is putting together your BOE Shield bot. And when you're done putting it together, it should look like that, with the exception of the circuits up here. You don't need to add any of these circuits, or these. Let's see. Here is an empty. Here is a constructed BOE Shield bot. Make sure also when you're putting the breadboard, or when you're putting the board on the chassis, you want to end up with the breadboard, the white breadboard, roughly above the two drive wheels. You don't want it over on the other end here. Okay, that pretty much concludes this session. Can I answer any questions before we stop the recording? And then after we do stop the recording, we can hang out and do any troubleshooting. And also there's time available after the session for any questions or comments that you might have. And then, like I said, we can also help you troubleshoot anything if you had any trouble with your Arduino connection during the workshop session. And aside from that, you're welcome to stay around. We encourage it. But also, if you need to sign off and get on to your next thing, just make sure to do these homework items between now and Wednesday, so that you'll have a fully constructed robot with a piezo speaker indicator that's tested and on your robot. And so we'll look forward to seeing you Wednesday at 3 o'clock Pacific time, 4 Mountain, 5 Central, or 6 Eastern, depending on your time zone. Thanks for coming, everyone. Oh, Stephanie?
One last question that may be of interest to viewers. Code was not in a loop, so how do the pins 12 and 13 still get the signal? You might want to explain that it's a set and forget command.
That is a really good question and a really good answer, Stephanie. Basically what happens is when you have this program that normally an Arduino program does its setup function once. That's all that. And then automatically it goes into a loop function that it repeats over and over again. Now, right now that's empty. And and so you might have, and so since I had 1500 as the last statement, the wheels did not turn. But I'll go ahead and set it to something even slower, like 1520. I'll set them to go the opposite directions and 1480. And if we run this, what you're going to see, I want to plug the battery back in. What you'll see is the servos will go sort of slow in one. Oh, I need to turn on the power. Okay, so we'll restart here. So the servos turn slowly in one direction, then in the other direction, and then they're going to return really slowly in opposite directions. And the reason for that is because servo right microseconds is a statement that continues to go after the Arduino has left it behind for the next statement. So if the next statement is serial dot print hello, this will continue delivering signals to the servos in these configurations. And this will just, you know, it'll, oh, sorry, I didn't see that I had that in the wrong spot. Okay, there we go. It'll print hello, and then it'll jump to the loop, and in this case, do nothing. But the signals that tell the servos to go counterclockwise and clockwise are still being delivered. And those signals look like this. They're brief high signals that turn a light on. And so in the student version, when the students are going through the book, they built some light circuits, and the lights, the signal is so rapid that it's 50 times a second. So you can't actually see the light flicker, but it appears to be a dimly lit light. And the students actually turn the light on and off at human speed and then make it go faster and faster. And then they see the dimly lit, which is this full speed signal, which the amount of time the light stays on is equivalent to the signal that makes the servo that either tells it to turn counterclockwise or clockwise at a given speed. And so it basically does this signal over and over again, 50 times a second to each servo until you tell it to do something other than that. And so there can be all kinds of stuff not related to servos happening in the loop here, but the servos will keep on turning at this speed simply because that's the last speeds. That's the last servo right microseconds command that it received. And so Stephanie used the expression set it and forget it. And that's the best way to think about these is that you set it, and then you can go and do something else. For example, delay for 3 seconds. Well, those signals kept on reaching the servo 50 times a second for those 3 seconds. And it's a very brief high signal that is repeated 50 times a second. And then the length of time that the Arduino sends the high signal is what controls the speed and direction of the servo. Is that okay?
Yep, we got it understood, and thanks.
Okay, excellent. Okay, so we can stop recording. You're welcome to hang out for a while, and we can do any discussion or troubleshooting that you might have in mind. Thanks for coming.